Hello and welcome back. In this section, we're going to be covering a topic called Exploratory Data Analysis, or EDA for short. Now, this is going to be a very fun section because we're going to be directly playing with data and arriving at conclusions just by how we visualize and how we cut and slice the data. This is a very important skill to have as a data scientist, and sometimes it proves more useful than machine learning. So, machine learning is a very hyped up term, something that's thrown around a lot these days, especially by companies who want to jump on the AI train. And many people don't really realize that you can do a lot of work, you can arrive at a lot of good conclusions, useful, valuable conclusions by performing heavy data analytics or, just exploratory data analysis. Because many companies, they might have a lot of data, but they haven't taken a look at any part of their data previously. So there's no real rush to go and apply machine learning on that data before you even have a sense of what you're dealing with, right? Just visualizing that data, getting it into reports, playing around with it, cleaning it up will give you a lot of insight. And sometimes these insights will be more than enough. In any case, even if you're going to be applying machine learning, you should always do some exploratory data analysis or EDA beforehand. And this will give you a better idea of what algorithms to use, what models to build, which features to train your models on, etc. Up until now, in this part of the course, in the machine learning part of the course, we've covered data preprocessing, and we've actually built a simple model from scratch. And the model was a linear regression model. The reason I put that in was because I wanted you guys to get a sense of what machine learning actually is, what it actually means intuitively to build a model. So in my opinion, that section is very important. It's very crucial. But after this section, we're going to be relying more on existing libraries or packages or pre-written code to build a lot of our models, because there's no reason to reinvent the wheel. People have built and optimized a lot of these algorithms for us, and they've fine-tuned them and also given us control over the parts of the algorithms that do differ from problem to problem, the parts of the algorithms that we would want to tweak. So before, we got into all of that, I wanted to give you, a sense of what it is to actually build and train a model, what it actually means. So I would advise you to go back and review that quite often. And also the data preprocessing in these sections are also very crucial to go back and review. The following sections are going to be more repetitions. We're going to be solving different examples using different algorithms. So they're not as crucial for in the long term, because once you get a sense of these three sections, it should be pretty easy for you to start learning new algorithms when you need to, learn about new models, new libraries, and that kind of stuff. Having said that, let's go ahead and start this section, which I'm quite excited about, especially when we get to the coding part. So what is exploratory data analysis? Exploratory data analysis helps you develop an understanding of your data. You should never work on your data blindly. You should always know what's there, what are the features there, know some characteristics of those features, of those variables, and just get a sense of what's happening in the data. And the primary engine behind exploratory data analysis, the primary impetus that's going to be pushing you and showing the way in terms of what you should do specifically during your EDA, is asking questions. You have to ask yourself questions. Look at your data and ask yourself a question. What is this variable for? What is the unit for that variable? How many instances are there? Are there, more than 5 unique cases of this particular variable? What is the distribution of this variable, right? Or how does this one compare to that one? All the instances unique. What if we remove a column? Are they still unique? Right? So there are so many different questions you can ask. These are general questions that you can ask for any data set, but then specific to your data set and the domain you're working within, you can ask even more specific questions, right? If you have like a data set of cars, you can ask, which models performed better, or which companies had cars that can travel a longer distance, or whatever, based on your specific data and domain. So you have to be asking questions. Most of the time, the questions that'll pop into your mind are the same questions that the people giving you the data are also curious about, right? If you're working at a company and you're getting data from the sales department, the marketing department, from the consumers or whatever, the executives, the board of members, they want to know, they want insight into this data. They want you to be able to answer very simple yet important questions on the performance of the company, on where the trends are going, and so on and so forth. So asking questions is the impetus behind your exploratory data analysis. It's what's going to lead the way. And exploratory data analysis is something that's actually not very easy to teach. The reason for that is, like, in machine learning, you have models, they're mathematically defined. It's, very clear what training a model means. It's very easy to show that, as we did in the previous section. And everything's very clear. The steps are there. The possibilities, the hyperparameters that exist, are clearly defined. Which ones refer to what part of the algorithm. Everything's very clear. But when it comes to exploratory data analysis, it's a very creative process. It's fundamentally creative. It's almost like an art, because every data set is different, and the way you explore it and the conclusions you'll arrive at, and even the questions you should ask for each data set, will differ. And the outputs, the plots, the results, the metrics, all of the stuff you're going to be getting as a result of your analysis will be different, and you will need to develop an intuitive understanding of how to properly, depending on the data. So it's a very creative process. Some people might be better at it than others, and it's not something that's very easy to convey. So what I always find is it's best just to show people what's possible, to just show them examples, even if it's a very unique or specific example to a particular data set, just so their understanding of the possibilities of such an exercise, right, of doing exploratory data analysis expands, right? They're able to see what's actually possible, right? Like, oh, you can plot the distribution of different numeric variables, and then based on this comparison, select a categorical variable and then see the different classes for it. Or, like the different paths you can take, the different routes you can take while exploring data. As somebody exposed to it on a very specific example, start broadening their horizons in terms of, them realizing what they can do with data that's given to them. So aside from that, the only other thing I can say is, you have to practice a lot. Whenever you come across a data set, it doesn't matter wherever it is, on the internet, on a website. I showed you guys how to extract data, websites, and then scrape data off of websites. So wherever you encounter data, pull it into your RStudio session. By now it should be intuitive, getting that into your RStudio session, and just start exploring, start asking questions, start analyzing, start plotting, start answering the questions that pop into your head. So that's what's going to make you really good at EDA. And honestly, I would say that EDA really sets data scientists apart from others, because you can be a very mathematically inclined person and really understand machine learning and just be able to apply machine learning to different data sets. But if you don't really know how to do the creative process of exploratory data analysis, you're not going to be able to progress that much, right? Whereas you might not have a complete understanding of machine learning, but you know how to use it when you need to, yet you have a very powerful understanding of exploratory data analysis. Your analyses and your results will be far more valuable than the former. So with that, let's define some terms that will help us better understand how data is structured so that we can analyze it properly. So a variable, I've been saying variable a lot, and I've also been saying feature or column. It's all the same thing. It's a quantity, quality, or property that you can measure. So it's a single quantity or a single quality or a single property, like hair color or hair length or height or model of car, kilometers driven, whatever. It's a single quantity or quality or property. So it can't be mixed in the hair color and length. You write a description in each cell. It can't be something like that. It has to be very distinct and a single quantity or quality or property, and it should not be spread across columns as well. And then a value is the state of a variable when you measure it. So that's the individual value. So like, let's say hair color, right? You have blonde, brown, and red, let's say. So red would be a value. It's a possible state of that variable. So the variable would be hair color, and the values would be red, brown, black, for example. And an observation is a set of measurements, several values each associated with a different variable. So for example, a person, might have hair color, height, and eye color. So the data set might consist of these 3 variables, right? And each of these variables have different values, but a single person will only have one value for each of these variables. So a single person might have red hair, brown eyes, and might be 6 feet tall, right? So this combination of measurements of values across all these 3 different variables for this one person is an observation. So when you're dealing with data sets, you should make sure that each row is a single observation. You don't want there to be a row that contains data on one person and then on another row also data on that same person. You want to merge everything together so that each row is a distinct observation of a set of the measurements as defined by those individual variables. So now, as data scientists, we're generally working with tabular data. Now, when you go into NLP and dealing with text and voice and videos and that kind of stuff, you might find yourself working with unstructured data. That's a very niche domain or a very specific area within data science. So, this course and then not many other courses, will cover that in depth. But most of the time we're working with tabular data. So a tabular data refers to a set of values, each associated with a variable and an observation. So tabular data is any type of data that you've probably seen in spreadsheets and Excel and or Google Sheets or whatever. But in our case, we want the data to be tidy. And we've covered this topic before, but I'm going over it again because this is really important. You want your tabular data to be tidy if you want to be able to do proper analysis on it. And it's tidy only when each value is placed in its own cell and not spread out across other cells. And each variable has its own column. So hair color, for example, is just one single column. It's not spread out across multiple columns. And each observation is its own row. So like we said in the last slide, you don't want to have 2 observations or 2 rows referring to the same measured object, right? So if your data is not tidy as such, the first step would be to get it to be tidy, right? Before you can do anything, just make sure it's tidy. Make sure that, sometimes you might have data where like they've combined 2 different variables into a single variable, like country or like, let's say state and city. And the column contains state and city information. So that's 2 variables. That's not tidy data. You want to split this into 2, state and city. Same thing with observations, right? You want to make sure that each row is unique.